that's like that. And what I want to do today is so we're going to take a little bit of a step back and talk more about compilation and what's going on behind the scenes. And then we'll switch back to talking about pointers and structs. So again, what a compiler does is it takes C code. So that is a program that's written in C. And then it makes an executable file, so something that you can run on your computer. So the computer or your phone or kind of anything these days is actually running an operating system. So that's the software that's always running, and that software takes an executable and actually makes it run. So it's a little bit analogous to how the Python interpreter takes a Python program and runs that, but the Python interpreter is kind of like one level above, in the sense that the Python interpreter is itself a program, like Google Chrome is a program, like Firefox, whatever, like VS Code is a program. And then inside that program, it runs Python. C code generally is compiled to executables, so something that's at the same level as something like VS Code, which in fact is like mostly written in C++ and was compiled and then it runs, right? So there are multiple compilers for C, so multiple pieces of software that take C code and produce executables. So what's installed in ECF is GCC. Clang might be there as well. You can install GCC on OS X reasonably easily. You can install it in Windows with medium levels of difficulty, which is why this year I actually suggested that people remote connect to ECF. But if you want, you can install MinGW. It works some of the time. It's a little bit annoying. So like the remote connection to ECF is also a little bit annoying. I would say comparably so. But if you want GCC, you can install it, or you can remote connect to ECF and do the examples from today this way. So what VS Code does when you press the run button, the play button, is it compiles, gets the executable, and then it runs the executable. So behind the scenes, it's running this program called GCC. Let's see how that works. So I am on my own local machine. If you can get a very similar thing, either on your local machine or if you connect remotely to ECF. So over here, I'm in this folder called desktop, and then whatever 190.2024, and then in the W4 folder. In this W4 folder, I can find out what files are stored right now. And the answer is A.C, A.H, and also A. A is the actual program that got compiled from before. So on a Mac, you would say ls. On Windows, you would say dir in order to get the list of those files. You can also, of course, like I can, for example, say open, and I can see that in W4, that is what I have this way as well. By the way, did I press broadcast on YouTube? Yeah, I did. Okay. So I can also run this program manually by saying, stop sharing. Why did I resume? Okay, so I can also run this program like this. Hold on. Oh, so I can run the program like this. So I would say ./A, and this would run this program A. It happens to print hello world. I can also go to my AESC folder, to the lectures over here. And on some computers, I can just double click on this program here and it will run. On my particular, so on yours, it probably would work. On mine, doesn't really produce anything. Usually on your computer, if you just double click on it, it would open a black screen for a second, or a white screen probably on Mac, and it would flash the hello world thing. Right? So that's a program like any other program that you can have on your computer. Now, the difference is the way we do input output usually is we print to the console, right? So we print to something like this. Of course, kind of like in the last 20 years, most output is like graphic. You open a window or something, and we saw examples of how you can do it with the Pong thing last year. You can do something analogous, of course, in C as well. It's just that we don't really deal with graphic output in this course very much. So, okay. So if I want, I can compile things manually. So the way that works is I type in GCC, and then if I have multiple C files as part of my program, I just say, my program 1.c, my program 2.c. And then after -o, I give the name of the executable. So for example, myexec.exe. So on Windows, it has to be something.exe, or it's not a valid executable, or, well, it is, but it won't run until you rename it to .exe. On Linux and Mac, no. But on Linux and Mac, you can still say my program, I want it to be named myexec.exe. So I'll do it here now. So I'll say GCC AC -o. It can be named anything. So now the program is there, and I can run it like so. So notice that I didn't have to type it. So if you press tab, it will autocomplete on Linux and Mac. I don't think on Windows necessarily. So that's like that. And I ran it, and it prints hello world to the screen. That's what the program does. Okay. So ordinarily in this course, I would rather work with VS Code rather than with this. The reason I'm showing you this, though, is that when we are dealing with multiple files, it's still the case that I would rather work on VS Code, but you kind of need some understanding of what's going on behind the scenes in case there are problems, which there can. Okay. Questions so far? All right. Yeah.
This the line BCC A.C. What does that do?
So GCC is the compiler, and then I tell it compile this file A.c. So A.c is this file. So it says like take, in this case, the C code in A.c and produce an executable that's named this. Make sense? Yeah. We'll get to that. But for now, it shouldn't actually be there. Yes, because you don't have an A.h. Yeah. We'll get there in a few slides. Yeah, so for now, it wasn't actually yet supposed to be there. Thank you. Sorry. Okay, questions so far? Are we good? Okay. So header files. So we can give the compiler instructions for tasks that are performed before compilation. So in particular, hash include basically says, here is a file, just copy and paste the contents of this file as if it were part of the program. So, for example, I have this file a.h, which currently is empty, but I'll put stuff in there in a second. And I can just say whatever is in a.h, just copy and paste it into a.c. Okay. And that is what include a.h does. All right. So, for example, and that's the usual way that we saw things being used in Python when we did import, I can define a function or something, right? So I can say print height. And I need to, so here, technically, I won't be in trouble if I don't include stdio, because what would happen if I do this is this line just says like, it's as if I just copy and pasted the entire thing into a.c. And stdio.c, which is needed for printf, is already included. But if I want to avoid the warning here says that printf is undefined. And fair enough, in a.h it is undefined, except I'm not going to use a.h by itself. But there's no harm in also saying here include stdio.h. So that's like that. And if I run this, so on your computer, it will not necessarily work. Currently not on my computer either. File format. Yeah, so that is fine. So here I can also say hi, like so. And if I run this, I have hello world, and I called my say hi. This is not the usual way that header files are used. This is just an example. That's what include does. So the difference between the angular brackets and the double quotes is that the double quotes mean that a.h is somewhere in the same, essentially in the same location as a.c. So somewhere where if I say to GCC, look up a.h, it will find it. The angular brackets mean that stdio.h is together with all the other standard header files for C. So not in the current folder, but there is a folder where all the standard.h files are, and the angular brackets say to the C compiler, go and look where all the other standard H files are. Right, so if it's a custom header file, you would use the double quotes and you would place it somewhere. Usually in this class, it would just be in the same folder as the C files as well. Make sense? So, all right. So that's the basic example. We'll fix it up so that it's a more usual later on. So in general, anything that starts with a hash is a preprocessor instruction. So hash include is one example. So this is another example. So what define does is it basically says do a search and replace. So if you say define pi 3.14, what it does is before the compilation happens, anytime it sees pi, so not quite search and replace because it's pi that's not part of a larger string. But if it's pi that's not part of a larger string, it just searches and replaces any occurrence of pi with 3.14. So this is not quite the same as defining pi as a variable because it's a search and replace. So it's faster than defining a variable because you're not spending any extra time defining the variable when the program is running because you've already searched and replaced before the compilation happened. It can cause difficult to fix compiler errors, right? So that's because if, for example, you decide, oh, this should be a string, I'll put it in double quotes. If you said, well, it's supposed to be a string, it's a variable of type string, then that could make it so that if you're confused about whether it's a string or an integer, the compiler will catch that. If you're just doing a search and replace, well, it's as if you mistyped and just like typed quotes where you didn't mean to type quotes, and it won't be in the same place in the code, so it can be more difficult to find errors when you compile. So that's a trade-off. And usually, again, kind of the reason you would do this is that it's slightly faster to do it this way sometimes, but in modern times, probably you don't want to define this way. It's probably better to define pi as a variable, because that can kind of prevent some compilation errors due to typos and stuff. So, okay. Hold on. Oh, my Chrome has died. Okay, we're restarting. Yeah, and it's frozen as well. All right. Unmuting myself from sharing. And we are recording, so we're good. Okay. So that's like that. So one use of a combination of header files and preprocessors is if you want to define a struct. So when you're following along here, what you should do is you should create a separate folder. So for example, my folder is W4, and then you should open the folder with VS Code. So open folder, and then here I'm opening the folder W4. The reason for that is the thing from before. So behind the scenes, GCC is running. GCC needs to be in the correct folder in order to read in the header file. Right? So here is a more usual way to use header files. So I'll say struct type def, struct student. Okay, car name, car age, student like this. I'll save this as student.h. And in here, I'll say include student.h. So now that I've included student.h, I can over here say, for example, student s, and then whatever, s dot, this is incorrect, by the way, s dot age is 20. So what happens when I say include student.h is as if this thing had been copy and pasted. So it's as if it had been defined in a.c. And that means that I can use, for example, s.h. So this is fine. Now there is one kind of subtlety. In C, you cannot define things twice. And if you have multiple files where you're using student in each of them, that creates a problem because you would say whatever GCC A.C, B.C, and if both A.C and B.C contain the definition of students, that will cause a compilation error. And it would be like that, right? Because if you say here, this is B.C, I'll save it as B.C. And then in here, I also have a student s, so that means that I need to include student.h. Then if I compile A, C, and B, sometimes it would work, to be honest, but sometimes it would not. If I compile both, that means that I've included this thing twice. So for that reason, what people do is they define include guards. So that works like this. So we say if student h is not defined, we define student h. We don't even say like student h something, we just define student h. And then it's defined like it's nothing if you use it. And here we have an and if. So what this does is before you run the compiler, so this is kind of like not part of the compilation process. This is like search and replace stuff before you actually do anything. And this says, hey, like, was this student h thing defined like anywhere at all? And if it was, well, it means that you've already included student.h, so you don't do anything. So the hash if, basically, this thing is not copy pasted if student h was already, if student underscore h, if this thing had already been defined. Make sense? So that's kind of the usual thing. It's like you always do this when you define header files. And we're not going to use hash if in any other context. It's just a thing that you do in order to avoid compilation errors that happen because you say type def struct student blah 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 twice. Yes.
What is pound and nifty exactly?
That's just kind of analogous to like open curly brace, close curly brace, right? So this says like just paste it in if the condition is true. Don't paste it in if it's not true. The highlighted part.
Like the whole rest of it.
Yeah, well, before hash if and end it. Yes. Yes.
What is like capital student H? Is that a variable?
It's
a tag? What is it?
I mean it's a macro, so it's like just like you define pi, you define student H. No, it doesn't. It's a name.
Oh yes.
It's just a thing. So we're saying if it hasn't been already defined, well, paste this in, and run this, I guess. And what this does, among other things, is it defines student H so that the next time the compiler encounters this block, it just gets ignored. Because if student H is already defined, then this is just not pasted in. Make sense? Yeah.
At the end of the on line 7, the student, is that just the syntax?
So this is the syntax of the type def, right? So if you remember, the definition of the struct is the highlighted part, and then we're saying type def this struct, and it so happens that we also name it student, right? So struct student and student are different things. They happen to be similar. Yes.
What is the difference between using the hash if and hash end if rather than just a normal?
So a normal if statement would be compiled and then run. This is the preprocessor, so this is what happens before we do any compilation, right? So it's also a program, like you can program this way as well, but this is kind of like before you do anything. And it's different than normal C, right? So for example, it doesn't have types or anything, right? So student H doesn't have a type. But yeah, like that's like, in a way, it's like a small programming language inside of C, specifically for doing kind of search and replace kind of stuff. But you also need if statements, and this is how the if statements work. Yes.
So, say we have multiple structs or multiple functions, we do this for every single one of them?
Well, so in general, yes. So this is kind of per header file rather than per struct. Maybe that's what you're asking, right? So you can define multiple structs in here. Here it just happened that it was the one.
Oh.
Right. So student H is like refers to the name of the file, although again, student underscore H in all caps, that's just a name. It could be anything. Okay. Okay. So that's like that. And now we can run code like this. Again, this is probably going to work. It did. Yeah, so in order for it to work for you, what you probably need to do is to open the folder. And the reason for that is, yes, so so basically what happens behind the scenes is you are running something like gcc a.c, and in order for this to work, it needs to be the case that student.h is actually in the correct folder for GCC to find it. The easiest thing to do is to open the folder in VS Code so that VS Code tells GCC, I'm in this folder, this is where you look for the H files. All right. So while we're on the subject, we have not done math.h yet, but good a time as any. So if you want to use math functions, like for example, square root or something, you encounter this kind of issue. So I can say now double equals square root of 4. And let me print it. So on some computers, that's going to work out, including mine. On your computer, it probably would not work out. And the reason is that you need to say GCC minus LM A.C when you're compiling it with GCC, again, on most computers. And that's because minus LM tells it, actually, this is where you find the actual binary files that correspond to math.h functions. C is complicated that way. So if you encounter this issue where it compiles, but well, doesn't actually compile when you try to use something from math.h, then what you need to do, and unfortunately, that's just how life is you need to go to configure tasks. And in configure tasks, you need to go over here. And over here, you need to say minus LM like so. That's live. Sorry. Although, well, on my computer it works without. But yeah. So terminal configure tasks, add the -lm, and this says like this is basically like the instructions for how to run GCC, right? So when you're running GCC, it says put the file in here and then -o, and that's the name of the executable. And then you also need to say it, by the way, also say -lm. And here it's like various weird settings as well. All right, so that's for math. That's not for this week, but you might need it. All right, so that's that. Questions? All right. So the next thing I want to talk about is working with strings in C. Again, sorry, nothing's easy this semester. That's how it's going to be. So the compensation is you get to write things that run fast sometimes. So if you define a string like this, right? So you say car name, so that means that name is the address of the first character where supposedly a string could be stored. You cannot say this. Why can you not say this? Well, you didn't say what the value of name was. You didn't say what the address is. So you cannot say name is just some random garbage address, go and copy Alice there. You're not allowed to write there at all, probably. Right? So you can first say, well, name is the address that malloc gave me, and I told malloc to give me an address where I can write 100 characters. At that point, you can say, take Alice and copy it to address name. Does that make sense? Questions? All right. You can also do this. So you can say Alice is a literal that I just put in the C program. I just used quotes and I put it there. And this is saying, put Alice, this Alice, somewhere in memory, and then assign the address of the capital A to name. That's allowed. That's okay. Two problems with it, though. So one, as you remember, Alice, if you input it as a literal, that's a const car star. That's not really a car star. That means that if you try and modify the contents of name now, that could potentially crash. You're not allowed to do that. Except the compiler will let you, but if you try, the computer might crash. Also, if you view this as one big program, well, of course, here the program might have crashed already, but if you got to this point, then what's happening is you have a memory leak. Right? Because you said name was the address of this block that malloc gave you. And then you say, forget that, overwrite name with the address of the A from this Alice. That means that you've lost the information about the address of the block that this malloc gave you. So there's no way for you to free it if that's all you have in the program. So that's definitely a memory leak. Yes.
Does that mean that when you do name equals Alice in the background, there's a malloc happening?
No. Okay. The answer is no, but the intonation was wrong. So if you have Alice like this, you inputted it into the C program, so that's a string literal. So when the program just starts up, the literals get put somewhere in memory. So not at runtime. Okay. Makes sense. So this is kind of I think this is like a subtle point, right? So if you say hello world like this, and it's part of the C program. So what happens is when the program starts running, It says, okay, like I have those string literals in my code somewhere. I'll just stick them somewhere until I need them. Malloc is a different process. So malloc, as you get to the malloc instructions, as the program is running, it says, okay, I need to find some space, however much space the user told me I need to get. And it has to be that way because you could potentially say, I'm about to load a video that I need to play, and that would take a lot of space. I don't know in advance how much space. So you can't just like pre-decide, oh, just in case, I'll just reserve this memory. It makes sense to first like see, okay, like I'm about to download like a 1 gigabyte file. I need to allocate a lot of memory in order to store it. Right. So I think this distinction, if you didn't get what I was saying now, that would make sense. Kind of as you get more experience with this, we'll come back to talk about the big picture. So for now, that's like this. So name equals Alice is okay, except if name was already a different string that was malloc, that's a memory leak. And also, if the string is a string literal, you're not allowed to modify its contents, meaning the compiler will let you, but the program might crash when you're running it. So the other option for storing strings is a character array. Yes.
So you can, it's okay to change the variable name, right? Like what is stored in name, right?
So it's okay to do something like this. So I can say name is this, and then I say, never mind, name is Alice.
That's okay.
The compiler is okay with it. If you are doing specifically this, what's going to happen is you're going to lose the information about where the malloc block is. So that means you cannot free it.
Okay. Yeah.
So, but that's like not the compiler's problem.
And you're not in like undefined.
Yeah. This is completely fine. It's just that this happens to be a memory leak. If you just look at like name was Alice and now name is Bob, completely fine. Yeah.
What if we tried to modify name at 1 or name at 2? Would that be a problem?
So if you do it over here, that could potentially crash. If you do it over here, that's completely fine.
It would crash because it's not sure.
No, it would crash because this is really a const char star. So if you try to modify the contents of a const char star, that could cause problems. Yes. After it's the same thing. It's not about A or not A. It's about whether this block of memory is read-only or not. So const char star. So this is read-only. Make sense? All right. So the other option is character arrays. So this here, let me make it like equal to Bob or something. So this is a different thing, right? So this is an array of elements that happen to be characters. So I can strcpy something else into name. That's completely fine. Arrays cannot be reassigned. So name equals Alice is just a compilation error. All right. So the other thing you can do is like name at 0 equals A, completely okay. Right. So that's to recap the two options, right? So you have an array. An array, you can think of it as it happens to have characters, but it could be an array of ints or something. You cannot reassign to arrays. You can modify the contents of arrays, no problem. We also had a different issue with arrays, which is you cannot pass them outside the function, but that's a separate thing. Yeah. That's overwritten, right? So it's just like you're saying like name at 0 used to be capital B, and now it's capital A. And name at 1 used to be O, and now it's L. Yeah. Yeah.
At the side of the array when you're comparing it to like reallocate.
Yes. So this is saying I'm gonna have a block of 200 characters. Yeah. Yeah.
It's equivalent to malloc.
It's not equivalent to malloc. It's a different thing. So we are defining an array that's defining. I'm gonna have, so in this case it's specified. I'm gonna have an array with 200 elements, and I'm initializing it with B, O, B, and then a null, and then a bunch of stuff that I'm not using. Right. And then I can write to any one of the 200 elements, or I can write to several of them at once using strcpy, right? So what is strcpy? It's like name it 0 as A, and name it 1 as L, and name it 2 as I, and so on. Right? So that's arrays. And the only thing that's special about character array, like there's nothing special about character arrays really, but you can initialize them using the quotation notation. And you can say, like, if it's a valid string, you can strcpy it. So strings, if you store them as just pointers, that's just the address of some memory block, right? So if we didn't reallocate it, name initially over here is just nothing. So you cannot say name at 0 as something because name is not a valid address. And you cannot strcpy to it either because that's the same. That's saying take Alice and copy it over to address name. Well, if address name is not anything in particular, you cannot do that. You can say name is this address now, which malloc gave you, and then you can write to it. Right? So that's like that. Strings and structs. So we already had this example with student, and there's two, and this comes up a lot actually in practice. So you can store an address of a name, or you can store the actual name inside the struct, right? So the difference is in my struct, do I just store one address where the string is going to live? Or am I going to store the entire 200 characters every time? Make sense? So this means that, again, the student H is over here. So here we have name like this. And let me define another student. That's like this. And those are two options. It's just that they have different implications. So in my program, so let me copy and paste this so that we have it in the same file. So in my program over here, I can say student S1. And then I can directly say strcpy s1.name John. That is fine because what I'm doing is I'm copying John into this array that has 20 elements. I cannot say I cannot say student with pointer and then strcpy s2 name. Because s2.name is not a valid address. It's just a pointer that wasn't initialized. I can say s2.name is equal to John, that is fine. Because what I'm doing is I'm just copying the address of this into s2.name, which is an address. I can also say s2.name is malloc whatever, and then I can strcpy. All right, so if I choose to say that what the struct stores is just the address of a name, then either what I do is I have a pre-cooked name and I just say s2.name is the address of the pre-cooked name, or I say s2.name, now that it's mallocked, I can copy into it. If I do malloc it when we're freeing, free s2.name. So in particular, suppose that I want a block of student with pointers. I can say, okay, I have an address of a bunch of students with pointers. Well, we're stuck again, but that's okay because we are out of time again. So I'm not sure what's going on. So I can malloc, so this would be malloc, and then I would need to malloc every name. When I free, I would first free every name, and then I would free the entire block. There is a question late in the lab today, if you're doing the lab today, where you can practice this, or we'll discuss it more on Thursday as well. I'll see you. Bye. Where do you see that it doesn't run? Because I see that there are some outputs. Did you open the folder? No, liquid file. I think you're actually in the ESC190. No, file, folder. No, file. Okay. Well, no, now you can. Yeah. Okay. Yeah.
Wait, you already started.
Didn't grab me. Well, you didn't tell it. Yeah, but you didn't hold the function. So, like, there is a function that's defined there that's called say hi or something. But you didn't call it. So you don't have to include STD. I suppose if STD always included before you include data. But it's always safer to include it because why?
Like, I remember when this one, you were just.
Oh, on that day, like 100, yeah.
Because there are two ways to define it. Here you define it.
No, so like there's only one way to define an array. An array can, yes, an array can get converted.
This thing like you define it in just like that. Like,
It's local either way. So the difference is. So the difference is between, so name is local, it could be an array or it could be. The difference is how arrays and pointers block for you to block for used or different. Right, so arrays, you can, so arrays you can always modify the content. If the block is, for example, on the star block, you cannot modify the content. Another difference is that array only exist while the function is running. You can return a name like this from the function and still.
Yeah.
the block.
Yeah.
Yeah. That's because string literals by you're not so it will compile. However, if you try to multiply something that was defined as a string literal, the program might a string literal is a string literal is a string that you include in the program inside. Well, no, so like it's this, so here, like you cannot modify this, but you will try it either because it's only over here and then you can copy the contents from here. So name is independent of value. Just happen to find here you're saying name is the address of this string. So then you cannot go to this, what you're trying to do here, you're trying to go to this string literal and modify, which you
So there's like but this string is time to the first like the time to the
That's right. That's right. And then you copy the address of this string. So
yeah, but so I can't modify the address because this name
you can, the address you can modify. You cannot modify the content at that. So you kind of go to address name and modify the value there.
But you can modify like for example this
No, I mean, like you can write something else, but in the program you kind of
the name is like
font stars.
Yeah.
Font stars. Heavy.
oh okay.
But like that, so like that notation, like you can go back to what you've done last week with that. That notation is not super intuitive. What's intuitive is just if it's defined in a string literal, you are not allowed to go and try to modify the contents. That's correct.
So that's the block.
Well, the block that it points to is not right.
The block is not true.
No, this block particularly. A block, I just use it as like any like any area in the memory table. It's just some areas in the memory table you're not allowed to move.
So every time like a point of the block.
No. So specifically, if it's a const block, then you kind of change them. Okay.
I had a really quick question.
Okay.
So if you define a block of the students with pointer, that would work same way as malloc should do. So
And the only thing that works like malloc is malloc.
oh, right, okay, so
So,
we define the block, then it's just thing.
so you mean as an array?
Yeah, no, with the pointer, if we define the block, like the very last line of code we wrote,
Right,
so that we define as a block.
right.
Is s dot name mutable then?
Well, I don't really like the terminology mutable because it can mean two things. It can mean, can I change the value of s.name, or can I change the contents at the address s.name? And the answer is you can change the contents at the address s.name, but you cannot change the value s.name if it's defined as an array.
Oh,
If it's defined as a pointer, you do that.
oh, I got it. Oh, thank you.
Yeah.
Thanks a lot.
Sure.
I'm wondering, like, before the weekend, what kind of topic was covered?
I mean, like we'll do more kind of procs and malloc and stuff like that, and then we'll possibly start some new stuff. So we have, I guess, 3 more weeks. So,
Yeah, like what the topic?
So it's not kind of set in stone, but yeah, so like the research answering because they don't remember the exact sequence, but like the sequence is basically what's in the syllabus. So if you look on the second page of the syllabus, there's like a sequence of topics, and then the answer is like as many topics in the syllabus as we managed to cover up until, before reading week.
So are you expecting like cover all the syntax you see before the weekend?
We don't expect to cover all the syntax and C until the end of the year. No, like there's a lot. So, well, like we're not really focusing on that. We're focusing on program, but not really. Look at the syllabus, there's like a few topics there, and then like just go through the topics, and we'll get where we get. So in general, we kind of finish up structs and the memory model, and we'll do abstract data types. Yeah. Yeah.
Oh, absolutely.
Yeah.
Thank you. Like
Yeah.
define another.
Long. Well, I mean, yes, but the key there is more from design part of it. Like designing data. Yeah. Well, so yes, kind of like I think it's like the most like what we kind of discussed at the end of the lesson today with different ways of defining student strums. So kind of like not so much kind of syntax, but more kind of should it be a pointer? So that's like a very simple example, but like should it be a pointer to name, or should it be an array?